let's practice another Kramer's rule. So this is the end of 6.4. Okay, so when you solve a system with Kramer's rule, you want to first set up your matrices, your d, dx, dy, and dz. So you want to set up your four matrices first. So start off with D, which is just the coefficient matrix. All right, and then we have dx, which is where we replace the x column, so copy down y and z, and then you're replacing the x column with a constant. Okay. So that's dx. Go ahead and fill out dy and dz. It is possible to have more than a 3 by 3, but on your test you will not have more than a 3 by 3. But if you do, then it could be like W, X, Y, Z. Like you do the same thing. Use your calculator to find determinant. Okay, so dy, I'm replacing the y column. dz, I'm replacing the x or the z column. So, okay, let's practice. Let's just do the graphing calculator. You did a 3 by 3 determinant by hand on your warm-up. We practiced it yesterday. So find all four determinants. So practice this, so if you have a question about it. So just checking in, your determinant of D should be 23. Okay, so of the D matrix. And then you need to do dx, dy, and dz. Okay, so dx should be 46. The determinant of dy should be negative 23. If you're still working. Okay. Okay, and then the determinant of dz is 92. Okay, so then to find x, y, and z, x is the determinant of dx over d. So the determinant of d is always what you're dividing by, so take d denominator. So that's 46 over 23, which is 2. And y is determinant of dy over determinant of d. Negative 23 divided by 23 is negative 1. And then z is the determinant of dz over determinant of d. And that is 4.
What did the question say for this problem?
So the question is just like this. Solve using Kramer's rule. Yep. So if it's a 3 by 3 system, meaning 3 variables, 3 equations, then you'll be finding 4 determinants because you got to find your original d and then dx, dy, dz. Okay. So show the work. Show these matrices written out, because then if you make a mistake, I can track to see where that is, and you will lose less points if it's just something minor like you wrote 1 instead of negative 1 here, something like that. Okay. And so then our solution is 2, negative 1, 4.
Are we not going to work with that?
I mean, I wouldn't expect any crazy decimals. But you can always plug them back in to check. Right? These, you can plug these back into X, Y, and Z and check to see if they're correct. So if you do get a decimal and you're wondering if it's right, plug them in and see if it works. Okay? Okay. So we can actually use some matrices to help us with some geometry. So what I'm going to do is calculate the area of this triangle. And I can do this with a matrix a lot easier than I could do without the matrix. So this is a non-right triangle. So I can't just use distance formula, Pythagorean theorem, can't do that. It also does not give me the height. So you know, if you find the area of a triangle normally, it's base times height divided by 2. Well, I don't have the height. So to find it, you would have had to find this altitude here. Okay. And then you would have had to figure out what this length was. And then you could use Pythagorean theorem if you wanted to find what this altitude was. Okay, so that would take a lot of work. So we can find area of a triangle for any triangle given this formula, now that we know how to find determinants. So all I do is I plug in my ordered pairs, my coordinates. It doesn't matter which one you choose to be x1, y1, x2, y2, x3, y3. So you write your ordered pairs. But to find determinant, you need a square matrix. So you have to make this extra column of ones. So this last column is always going to be ones. And then you plug in your ordered pairs. And then we use this formula, determinant of t divided by 2. This time this does mean absolute value, and that's only because we're dealing with area. Area has to be positive, okay? So if you get a negative, you just make it positive. That's all that's saying. So if I do this, let's set up our matrix T. Like I said, it does not matter which one is the first point, which one's the second point. As long as the ordered pair stays together. So -2, 3, 2, 6, 3, -2. And then I fill in this last column with ones. So let's find determinant of t. So type that in your calculator. Same way we just did. So for the determinant, you should get 35. So then my area is the determinant of t divided by 2. So 35 divided by 2, which is already positive. So, and I don't care, you're just dividing by 2, so if you write it as a decimal, that's fine. 17.5. And then we're talking about area, so let's be technical. Square units. I'm pretty sure I got positive 35. You got negative 35? Okay, all right. Okay. No, I hold on. Yeah, let's see. Yes, you should get negative 35. Good question. So, you get negative 17.5, but because it's area, you have to switch it to positive 17.5. Okay? All right, that's on your test. You'll have to know how to do that. A little rule about this. If the determinant equals 0, then that means there's not a triangle. So the points are collinear. They form a line. I mean, that makes sense, right? If your area is 0, then that means there wasn't, a triangle, a figure there to find area. All the points, the 3 points just lined up in a straight line instead of a triangle. So if the determinant is 0, the points are collinear, meaning they're on the same line. Yeah, or you could say like collinear, like the points are collinear. There's you'll see on Schoology like one of the multiple choice, one of the choices says like collinear. So we want that would just be over just like positive. Yep. Okay, so we're going to do one word problem, and then we'll be done with the notes. We'll talk through it. It tells us to use Kramer's rule, but we'll actually use the inverse matrix way. Just to review that, because I think we hit Kramer's rule pretty hard today. We'll talk about it. Okay. So here's my word problem, and it's actually set up pretty nice. Like it's not too hard to get these equations set up. We are going to use an inverse matrix. Okay, so we want to define the variables, write the equations, like set up the system, and then we'll do the solving, like using the matrices. So the question, find the cost of a pound of each fruit. So this time we're not looking for the number of pounds, we're looking for the cost of a pound. So just keep that in mind when you're solving and the answers that you get. So A is the cost of a pound of apples. K is the cost of a pound of kiwis. And P is the cost of a pound of pears. Okay, so again, the equations are pretty easy to set up. It's kind of written in order for you. So like the first one, 2 pounds of apples, 2 pounds of kiwis, and 10 pounds of pears costs $3.26. Okay, so that's just saying 2 pounds of apples, so 2 times the cost of apples plus 2 times the cost of kiwis plus 10 times the cost of pears. That total is $3.26. And you can do the same thing for the other 2 equations. So if you have 3 variables, you need 3 equations. Right? If you had 2 variables, you'd want 2 equations. If you had 4 variables, you'd want 4 equations. So we'll go ahead and fill in those other 2 equations. So 3 pounds of apples plus 2 pounds of kiwi plus 7 pounds of pears was $2.98. And then 2 pounds of apples plus 3 pounds of kiwi plus 6 pounds of pears is $2.89. Okay? Alright, so using an inverse matrix, we're going to set up that matrix equation. So this was what we did in 6.3. This is on your test, so you'll have to know how to do it. Everybody okay with how I set up the equations? Okay. So, when I use an inverse matrix, I'm going to set up this matrix equation. AX equals B. So A is that coefficient matrix. Okay, so that's matrix A. Matrix X is my variable matrix. So A, K, and P equals B is my answer matrix, so 326, 298, and 289. Okay, so what I'm doing is I want to find X, right? I'm trying to find what my variables are. So remember, to get rid of A, we're multiplying both sides by A inverse. Okay. So then the A inverse times A cancels, leaving me with X equals A inverse times B. So that is what I type in my calculator. So you're going to have to type in matrix A and matrix B. Okay? And then you'll type in A inverse times B. Remember, the inverse button is under math. So you'll type in matrix A and matrix B. Also keep in mind that you're looking for the cost per pound. So, you know, your answers, you're not looking for the number of pounds. So if you don't get whole numbers, that's okay, because you're looking for a cost. is a 3 by 3 and B is a 3 by 1. So you should get 0.29, 0.39, and 0.19. Okay, that's what you should get. So that tells me that A, so pounds of apples, so apples are 29 cents per pound. Kiwi is 39 cents per pound. And pears are 19 cents per pound. Okay, so here's my answer. So we have learned 3 ways to solve systems with matrices. We learned the augmented matrix, the triangularizing, where we had that triangle of zeros. We did the inverse matrix and graphing calculator. You have to use the graphing calculator for this because we did not learn how to do inverse of a 3 by 3. We've done determinants of a 3 by 3. We've done determinants and inverse of 2 by 2, but not of a 3 by 3. Okay? And then we did Kramer's rule. So it'll specify which way to use on your test. So it'll say use an inverse matrix, and I think it says and technology. Use an inverse matrix and technology, meaning use your graphing calculator.
So you don't have to do an inverse matrix by hand.
Not of a 3 by 3. Of a 2 by 2, yes, but not of a 3 by 3. So you want to show that work. So then I know that you use an inverse matrix. Okay, so I want to see this work written down. Okay? Questions about that? All right. You're getting close. We finished chapter 6. One more chapter to go.